Hello, everyone. Today, we will introduce you 7 most difficult problems in mathematics. Clay Laboratory, a laboratory created by genius mathematicians in the United States, selected it on May 24, 2000. It refers to 7 math challenges. The contest, commonly referred to as the Millennium 7 Problems, represents 7 problems that can contribute to the 21st century mathematics world, and only one has been solved with a reward of $1 million per problem. There is no time limit for this contest, and if you solve the problem and publish the solution in a professional journal, you will be paid $1 million in prize money if you believe there are no errors after 2 years of verification. They will go down in history as a man who have made tremendous contributions to the development of science and mathematics. So let's try to figure out how hard it is to give $1 million. Number 1. P versus NP problem. It is the only one of the 7 Millennium Mathematics Challenges that can be understood at the general level. It was proposed by American computer scientist Stephen Cook in 1972, and the problems are as follows. P is a problem that is easy to get an answer to, and NP is a problem that is easy to prove but difficult to solve. P equals NP, or is P not equal to NP? Number 2. Riemann Hypothesis. This hypothesis was established in 1859 by German genius mathematician Riemann. Riemann seems to have done some research, but the data was lost because the housekeeper accidentally burned the research, which has been bothering mathematicians for 100 years. If the housekeeper had not burned it, it might not have become one of the 7 major math challenges. In the Riemann zeta function, the real number of all non-self-evident zeros is 1/2. In other words, the 0 point of the zeta function exists in a straight line. Number 3. Yang-Mills existence and mass gap. As a theory of subatomic particles, which are smaller than atoms, the lightest particles also have a positive mass, a hypothesis that must be proved mathematically for this mass interstate. This hypothesis is an explanation for mathematically identifying the identity of the fundamental forces that make up the universe. Splitting protons and neutrons that make up the nucleus of an atom produces 3 smaller particles, the quark particles, which can explain the existence of forces that these quarks pull strongly against each other. Prove that for any compact and simple gauge group G, an unselfish positive Mills theory on R4 exists, and has a mass gap of greater than 0. Proof of existence involves constructing a strong axiomatic property, at least as in the cited papers 35, 45. R4. Euclidean 4-dimensional space. Hollow-up pointing triangle. The mass of the lightest particle predicted in the theory of mass clearance. Number 4. Navier stroke equations. This equation is a fluid motion equation that considers pressure and friction caused by the viscosity of the fluid and can be seen as a problem of obtaining a solution to the partial differential equation. Claude Louis Navier and George Gabriel Stokes proposed. It is used for research such as the flow of aircraft and the spread of marine pollutants. Find the solution of the partial differential equation that describes the flow of gas over the wings of an airplane and the flow of water like fluid over the side of a ship. Number 5. Pointcare conjecture. In 1904, Russian genius mathematician Gregory Perelman proved it in 2002 with speculation published by Pointcare. Perelman did not receive the Fields Medal and $1 million in prize money from the Clay Research Institute even after solving the difficult problem, saying that he did not want to be a spectacle like a monkey at a zoo. In 3-dimensional space, if a closed curve, can be aggregated into a single point, the space can be transformed into a sphere. Number 6. Birch and Swinerton Dyer conjecture. It is a question presented by Birch and Swinerton Dyer in 1965. The question is to find a simple way to know whether an equation that defines an elliptic curve as a rational number has finite or infinite solutions. The coefficient of the Abel group formed by the points of the elliptic curve E on the water body is the same as the order of the root at S equals 1 of the Hayes-Buell function. Taylor series at S equals 1. Elliptic curve. An algebraic curve that can be represented by y squared equals x cubed plus x plus b. Number 7. Hodge Conjecture. The conjecture published by Iliam Balance Douglas Ho is a conjecture on the algebraic cycle that any object is all a combination of geometry. It is a hypothesis related to topology. When X is a soft projection complex algebraic variety, all arcs of X are algebraic. That is, the arthropods of X can always be expressed as linear combinations on the rational number of the cohomologies of the partial algebraic manifolds of X. In other words, any object is a combination of geometric fragments. Thanks for watching.